can be up to 10 seconds. And finally, ultra short ranges, which ranges can be duration ranges can be up to 0.2 seconds. Once we classify our ranges, we select approved ranges and pass it from vectorization model, which gives us corresponding vector representations of that ranges. And from the first vector, we extracted a 2-second identifier, and we store it separately. Then we calculate cosine similarity between each vector and already stored identifier vectors. And if that similarity score is higher than predefined threshold, we assign that speaker ID to that segment. Otherwise, we found a new speaker, and we extract a new 2-second identifier, stored it, and update our initial hypothesis correspondingly. This process continues until all vectors have been processed. Then, for each filtered range and already stored identifiers, we calculate similarity, and we select as a label top 1 label ID. Then we process overlapped ranges. We also calculate similarity score between each overlapped range and current hypothesis, which already consists of approved segments and filtered segments. And as a label, we select top 2 labels with higher similarity scores. We done an experiment. We try to calculate attention. We try to use attention-like mechanism instead of cosine similarity, and we updated hypothesis in the previous, such as in the previous way. And to understand what causes more error cases, we calculate some statistics. We consider as error cases overlapped speech, small segments, and wrong label assignment. And the statistics showed that in approximately 85% cases, errors are caused by overlapped speech. And to reduce this error, we have trained an 8-layer transformer encoder, which input is overlapped speech as log-mel spectrogram and some speaker reference segments, also as log-mel spectrograms. And the goal of this model is to determine if the reference speaker presents in overlap segment. Then we replaced cosine similarity and attention-like mechanism with already trained model and update the overlapped speech hypothesis in the way as previous 2 cases. At the end of our pipeline, we do 2 cases of post-processing. Nearby mergers, nearby segments from the same speaker are merged if they are separated from a small gap. And we reassign ultra-short segments to their neighboring segments. We selected these open source data sets to test our model, our system, and in this slide represents the vectorization models which we have experimented, and on average, Titan large performs better results. So the other results will be presented with using that model. And this slide is our results with using cosine similarity similarity score. We compare our system with NeMo MSDD, SortFormer, and PyNode, which are open source tools for diarization. And we obtained better results compared with MSDD and PyNode, and comparable results compared with SortFormer, which is the best open source solution up to 4 speakers. When we try attention-like mechanism instead of cosine similarity, we obtain some improvement in our results. And finally, when we try our trained overlap model, we also get improvement compared to the previous 2 steps cases. This slide represents our results with trying color parameter value as 0.25, which is common for usual for diarization frameworks execution. And we also calculated system execution time, and we get faster performance than the open source solutions. And a few words about the limitations of framework. A maximum of 3 speakers activity is required within 10 seconds, which is the constraint of speaker segmentation model. And if a segment is shorter than 0.2 seconds, and its neighboring segments belong to different speakers, it will be discarded during processing. And to conclude, our objective was to develop a system that does diarization in more than 2 speakers, achieving faster results, not only accuracy. And we done the following tasks. We conducted a study of related work on diarization, developed the system, and tested that system on test datasets. Thank you.
Is your model language agnostic, or does it require a specific language?
Thank you for your question. The system overall can be language agnostic. It is based. It can be based of vectorization model, because can be trained on some language, some data with several languages.
Yeah, that's why I'm asking. You have your own model, right? So it's trained with some data. I just wanted to understand what languages.
We have tested on English, on Armenian, and a little bit on Russian. Other languages we don't test it.
So the data set includes these 3 languages.
What?
The data set on which you trained your model.
Our transformer encoder, we tested. We have trained on English, on Armenian, and on Russian data.
Okay, and do you give also different amount of speakers to your model, or it's prefixed like 2, 3?
If your question is about,
if you go back to that slide, maybe. So what is this last metric, the check part?
There, diarization error rate.
Sorry?
Diarization error rate. If you ask about this model,
6 segments, right?
yes, here overlap segment is just 2 speakers overlap segment, and the reference speaker segment is a single speaker reference, some segments up to We selected up to 15, I think.
Up to 15?
Yes. But it is a single, one speaker.
Yeah, I understand. You
Mhm.
just pick a sample page,
Mhm.
and then you also kind of give the references up to 15 reference
Yes.
speakers, and also overlaps, where each overlap is only 2 speakers.
Yes.
Thank you.
Other questions? Is your system open source? Is it available to use?
Not yet. I
I
think I don't know it can be open source or not, but there is no such information yet.
But maybe do you have plans like to provide API to use it or some commercial use?
Not yet. Not now.
Yes, the answer is I'm not the right person to ask.
So the first question is whether you considered, I have asked, how many speakers can it
Distinguish?
specify at once in overlapping sections? Only 2 or 3 or more?
In this case, or
In general.
in general, Diarization, how many speakers?
No,
Overlap? Overlap? Yes, only 2. Only 2. Yeah.
And is it known before the speech utterance how many speakers there are there, or
Not.
is it decided by the classification just online?
Да. Yes, owner.
Okay, thank you. And another. Yes, I have a question following the question on the first guy. Have you tested whether the same person who speaks, for example, Russian and Armenian is classified as the one, exactly one person, or it splits into 2?
Same person
Say-
speaking on different languages.
Yes,
Mm,
same
Is it classified
No,
as-
I
as a
don't
single
remember
person
such
or
cases.
2 persons?
The overlap and reference was in the same language. We don't try to this in different
So
languages.
if you have, let's say, a mixed meeting, as mostly all tech meetings contain English terms, something, even if it's in Armenian or in Russian, usually people use some terms. I think the question is, if we have a mixed language conversation, will the same speaker still be identified as himself, or there might be?
Because the data is collected from open source, from YouTube or in such places, there can be cases when in a single audio are spoken in different languages. I don't set an experiment that you said, but I think it can distinguish. It can find that it is the same speaker.
One question regarding the vectorization part. So you use a separate model for vectorization. It is a speaker embedding like vectors, yeah?
Yes.
And you use Titanet model. Yeah. Have you tried other algorithms, or it is?
Yes, we have tried with speaker models some models of WeSpeaker and some models from VoxBlink, which also are vectorization models. But on our experiments, Titanet on average gives better results.
What about icapati-DNA? Have you tried it?
What?
Icapati-DNA.
Yes, it was worse.
So maybe the answer to your question partially depends on the model of this method, Titanet, because if it's language agnostic,
Yes.
it can single method for different languages in the same speaker. Okay, other questions? Also another question regarding the architecture of your main model. So it detects the overlapping parts, yes? Is it offline network, or it is capable to work online, like in streaming mode?
Yes, it can work on streaming mode.
In streaming mode?
Yes.
And what kind of streaming parameters, like chunk length, like
Chunk length is 10 seconds now, processing chunk length. And I think okay, chunk length is 10 seconds. 10-second segment is selected to process. And not on overlapping chunks. On overlapping chunks can be also up to 10 seconds because the input of the system is up to 10-second chunk. Because our trained data is also in that range.
And what about the complexity of the network, the parameter count?
I can't now say it. Here is.
But it will process 10 seconds, less than 10 seconds, yeah?
Mm-hmm.
The overhead network heads, basically.
Yeah, network size.
It's a small model because a segmentation model is small, and vectorization model is also small, and our trained transformer encoder model is also not such a big model. It has 8 layers, and I can't now say some.
Transformer layers.
Yes.
So you didn't measure the overhead delay, basically.
No, the overall sum of parameter I can't now.
Okay. Also, if you go to one of the first slides, I didn't get the different segments, how you come up with these different segments.
Okay, which slide? Here or?
The very first slides where you classified the signals as different types of segments, like short segment, approved range. Basically, what's approved ranges, filtered ranges, or whatever?
Approved ranges are a single speaker ranges, which duration is between 2 to 10 seconds.
Why specifically, and why is it called approved?
We try to, from approved ranges, we extract 2-second identifier to make a comparison.
By
then.
approved, you mean like manually approved? You know that this is the speaker? Or
No, just it is called approved for that reason that we later we extract the 2-second identifier only from that ranges, not from the other ranges. Just its parameter name approved.
Okay, and the other one, filtered ranges?
Filtered are their duration is between 0.2 to 2 seconds, and they after that approved ranges are processed. We process filtered ranges.
Just naming.
Yes, just names. Yes.
So from 2 to 10 seconds, you assume that it's enough for good identification of a speaker, and if you have only one speaker, that's why you call it approved. And then if it's less, then maybe it's not that good.
Because the input is up to 10 segments. Here ranges also can be up to 10 segments, and we on the experiments we found that 2-segment second identifier can be good, works better in most cases. Then, based on that, we classify in that way.
Okay, thank you. Now.